Hi, and welcome back to 8-Bit Resurgence. My name is Thomas. Sorry I've been away for a while. I haven't posted anything on my channel, primarily because I was developing some new products and working on some projects. And those are all going to be highlighted in some upcoming videos. But today, I want to talk about the 21-second backup. Now, if you've watched some of my other videos, you probably came across the one where I copied the Superfast file backup from the 21-second backup people, VG Datashack, and their version 4.1 as well. I thought it might be really nice for you guys to be able to experience this. You know, if you've seen the prices on eBay lately for this sort of thing, one of these discs here, this guy, sold for $199 US. And this one, the Superfast file backup, it was over 300 US just for the disc. And that's really, there really aren't that many around, and it really is too expensive for most people to get into when it does show up. Yet it's a really neat product, and it would be a lot of fun for a lot of people to try it out if they could. In a lot of cases, when this 21-second backup software or the package shows up, the original cable that it came with doesn't come with it. And there's a reason why, because this is an original cable here. I'll just kind of hold it up to the camera, and you can see how they attach the cable. It uses a kind of a plastic wafer on the underside that connects to the chip socket. Those broke a lot of the time. The way the connector attaches to the housing rips out when you're trying to pull it out of the 64, and then the cables will rip out because they weren't very adequately soldered for I guess long-term use. I guess the idea wasn't for decades and decades for it to be used, and they didn't factor in obviously age where this stuff breaks down. So the cable, I've managed to come across one cable that was actually reasonable, and that's that one that I just showed you. The other one that I came across, the chip beds were already broken off, and it was in very rough shape. So I thought, you know, it would be really neat to recreate that. So I took a cue from their design, and I came up with my own design, and that's what we're going to work on today. We'll build a dual drive 21-second backup cable from this kit of parts that I've created. Consists of a housing that the user port connector is attached to, and the wires go into. I created a nice label for it. Obviously the cable that goes between the two drives, and the attachment to the drive itself. I did that by creating a PCB that's the size of the 40-pin socket, but I made it very thin, 0.4 millimeters thick, and it's gold plated as well. Actually, with the gold plating, I didn't have a choice. When you go that thin, they can't, I guess, skim the solder on a PCB that thin, so you're forced to pay for the gold plating, which is okay. But then I solder that to the underside of the chip bed, and then that gets sandwiched between a machine socket and the socket that receives the chip from the drive. That turned out really well, and I'm going to assemble that today in the video. What I am going to do, I'm not going to make you sit through me soldering every wire and cursing if I burn myself. I'm going to just show you what I'm going to do. I'm going to tell you what I'm going to do, then I'm going to do it, and then I'll be back, with the magic of editing, mere seconds later, and you'll see it done, and we'll be able to step through the build process quite quickly. And I'll be able to discuss any little tips or tricks that I have in assembling it to make it easier. The idea was to offer it as a kit. Makes it more cost effective for you guys. It's pretty simple soldering, provided you have the directions, and I can provide that obviously with it. And for those that are have shaky hands or not good at soldering, an assembled version will be available as well. So let's get right to it, and we'll move over to my soldering station, and we'll get started on it. After we finish building it, then we will move over to the 64, and we're going to test it. So what we're going to end up with is this. And this is the 3D printed housing that I designed for this, with the user port connector. The two cables go through the end of it, and they terminate at the connectors that plug into the drive. So let's get started. All right, so here is the kit. It's actually kind of a combination of both. If you were to go with the double drive kit, it would look like this. It has the two connections for the drive, user port connector. There are heat sets embedded in the end, so that it can be fastened to the 3D printed housing, the label, and the two cables here. My recording setup isn't ideal, so you're going to end up watching me do this sideways. I'll orient it to the camera as best I can. All right, so the first thing that we're going to do is we are going to attach the cable to the user port connector, and that's done. We strip the ends, and then I use heat shrink to isolate the wires and solder mod. So I'll show you that as soon as I have that done. All right, so what I did is I cut a notch into each of the cables. This is one of them, and you'll see there. What I did that for is when you attach these 9 wires to this connector, it spans a rather large distance for this size of cable. And if you cut it into a V, then the ones on the outside have further to go than the ones on the inside, and it lays the cable down much nicer against the user port connector. If you leave them all the same length, then the wires kind of get jumbled and twisted in there more than I like, and then it puts strain on the solder joints, and I prefer not to do it like that. So that's why I cut that V, and then I just use the my X-Acto knife to split the wires. I do that. You can tear them apart with your fingers, but it makes a nicer cut with an X-Acto knife, and I just use a little flat piece of wood. This is just a ice cream stick that works quite well for that. It just prevents me from wrecking my pad. So I'll do that, strip all the wires, and prepare it for the user port soldering, and then I'll show you what it looks like before I solder it on. All right, before I solder, I know I was going to say that you'd see it after it's all bound together with the two cables, but I wanted to show you, I just tinned this one end here of the cable, and I splayed it out so that it's easier to solder, but here it really illustrates when it's attached to the connector, how when the wires are splayed out, they form a pretty decent straight line without binding up the wires here. So that's the reason why I started with a V, because I want to end up with the wires looking as close to this shape as possible when soldered on the connector. Okay, that's all I wanted to say at this point. I'll get to work binding the wires together from the two cables, and I'll get them ready to go onto the connector here. All right, so we're back, and what I've done is I've taken some clear heat shrink tubing that's just slightly larger than the two wires combined. This allows me to group them, each respective wire together. So zoomed it in here to hopefully you can see the clear heat shrink is probably not very visible, so it's right there, and I've grouped each pair of wires together. This does a couple of things. The heat shrink will go over each of the pin of the user ports as when it's soldered on, so that'll kind of grab onto the soldered on connection and isolate it from each other. And it's, as far as I'm concerned, the proper way of putting wires on a connector. So, and to get it there, you're not going to mix up the wires while you're doing this, because everything is grouped with its respective wire, so you can't make a mistake. So long as you paid attention to make sure that the top wire and the bottom wires are all in sync with one another, then once you soldered onto this connector, it's going to be okay. So now I'll solder them on, and I'll shrink the tubing over, and then you'll be able to see the connector, and then we'll continue on. Alright, now I finished soldering the wires onto the user port connector. As you can see, it fans out nicely like we had planned. Heat shrink tubing is all the way covering every solder connection. It took a little bit of time, but it was a little fiddly, but not too bad. So that I just shrunk that with my hot air workstation, but you can do it with a lighter. Just don't hold the flame on too long, otherwise you'll burn the wires. But otherwise it turned out quite nice. So we're going to move on to the next part now, and that's going to be soldering the ends to these two pieces here. So to attach the wires, it's quite simple. You just, again, strip the ends. This time we're just going to leave them straight. The red wire goes here, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. And you do that on both. It doesn't matter which goes in which drive once you're done. All of the wiring to the pins, and cutting off a leg and all the fun stuff that you have to do to make a 21-second backup cable is all built into this PCB. So there's no headaches, nothing to worry about. You just solder the wire onto those connection points, and then we'll just take the user port connector, put it inside the user port shell, and we're going to be finished. So as you can see, there really isn't too much to constructing one of these. Okay, so I'll strip down the wires, tin them, and then I'll solder these up, and then we'll continue on from there. All right, I've finished the soldering. I've attached both of the drive wires to the module that connects to the 1541. Notice this wire doesn't have a red stripe on it. It's because I took a wider cable and I split it. I don't have any 9-wire ribbon conductor. I have much wider stuff for other projects that I've done. So it doesn't really need the stripe so long as you take note of where the stripe is. So I put a little black mark. Probably can't see it in the video because you're too far out. But I just marked the red wire on this particular one that was unmarked. I just traced that down the wire from the user port connector that we soldered before, and it's all soldered. The back side is just the wires come from the top. Number 1 is marked on the board, and you just go 1 through 9 on both sides, solder them, trim off the excess conductor that pokes through the hole, and we're done all the soldering. So this cable is essentially done. We just need to now install the user port connector into the case. So that's rather easy to do. You just have to make sure you orient the cable in the case correctly. So with the bottom here, you make sure that the wire, the red wire, is on my left side. So it needs to be in this orientation, just like that. Because the wires for the 21-second backup go in the bottom row. So then you'll see there's a little indent in the case here. So we'll hold this here, and then we'll bend the wire into that hole, and we have a little plastic dowel that sits there. And then we just put the case on top of that, sandwich it in, make sure that the screws go through each side. So the wire comes out the end. Then we flip it over, holding it together, and we have some M3 screws, and we use a 2.5mm hex key tool to lock the case down. And make sure we push the user port connector down as we're tightening the case, and then we just tighten it down nice and snug. There, so that's tight, and then we just can't forget to tighten these little 1.5mm hex key M2 screws that were already in the user port connector, and there's a little heat set that's pressed into the end of the user port connector. So you just, it's not flush when you get it as a kit, and you just tighten it until it's flush. It actually pulls into the user port connector, and then you do the same on this side with the same hex key. You just tighten it and make sure it's nice and tight in there, and watch the heat set as you tighten it. Make sure it's flush, which it is, and we now have a finished dual drive 21-second cable that we will now take over to the 64 and a couple of drives. And we're going to try it out, and we'll use the I think we'll use the Superfast file copier, and we'll try formatting a disk on each side, and maybe we'll use the copy disk function, and then you'll be able to see how lightning fast it copies and how much fun you'd have using it. All right, so let's head over to the 64 and plug it in and see if we did a good job here and see if it works. All right, I took the liberty of connecting the 21-second backup cable that we just built right here, and turned on the monitor, and I plugged it into the drives. If you're thinking that this seems to be standing off pretty high, that is actually true, because I use these drives for testing. Rather than wearing out the socket on the board, I put a socket in that socket, so it's one socket higher than it normally would be. So let's switch on the drives. They cycle nicely like they should. All right, let's start by putting the Superfast file copier in drive 8. That's the light color drive. And we'll load it, ask it for 1 or 2 drives. Now this is going to tell us if the cable works at all. If it didn't work, it would complain. And that's all good sounds that it's making. It was supposed to make that on drive 2. All right, so we have the 21-second backup software, the Superfast file copier loaded. So let's log in a disk to copy. This is just some disk that I had in my collection. So let's load a directory. All right, and then so it shows the files that are on that disk, and then we'll switch to the working directory to a blank, and let's start by formatting that. Just call it anything we want. So now I guess I should have closed the door first, huh? Okay, let's do that again. All right, so it's formatting. And so that's empty, so we'll change the working directory to 1. So that's this drive, and then we'll tell it option A to copy the disk. Insert source is there, destination is blank, and we'll hit enter. And like lightning, it is blasting through that disk. That is really remarkably fast. And then it shows you a block allocation map of the copy from track 1 to 35. And let's do a directory of the first of drive 8. We change to the working directory. Let's do a directory of that. And they are both the same. So it looks to me like we were successful in the construction of this. All right, so we successfully built a 21-second backup cable, a dual drive cable. You can see it wasn't really that hard. It is a little bit time consuming. So when I do put the kits up, there will be an assembled option. However, I will have to charge for my time. So that'll add to the cost. And I highly recommend, if you've ever soldered or done any soldering or have any interest in learning to solder, this is a really nice little project to get your hands on. It's just soldering some wires, a little bit of heat shrink tubing, which also comes with the kit. It's quite satisfying once you have it all built and working. Yeah, so I hope you enjoyed this video. I have, as I mentioned at the beginning of the video, been working on some other projects. I'll give you a little sneak peek on it in terms of what they are. I have been working on my version of the reverse engineered 1581, and so I've done that, and I've come up with a new case design. There are some cases out on the market, or not on the market, but available for download, but they are not that great to print because of overhangs and so forth. So I came up with my own design. So I'm gonna, the next video or close to the next one, I'll be discussing the 1581 and putting one together, and you can see what that's like. But this was the 21-second backup, and I hope you enjoyed it. If you do like the content that I put out, please do subscribe and like. It would be greatly appreciated. Thanks for watching. I'll see you again.